Algebra 2, Lesson 1.6. Solving an inequality. Since we have a fraction, we can use the same technique we use with an equation, multiply by the least common denominator, creating a problem that does not have a fraction involved. 7 times 8 is 56, 7 times x is 7x, 7 times 6 is 42, 7 times 6 sevenths is 6, and then the x. Now we can solve this inequality. Add 7x, add 7x. 56 is greater than 42 plus 13x, minus 42, minus 42. 14 is greater than 13x, divide by 13, divide by 13. 14 thirteenths is greater than x. Then it's usually easier to graph if we write this with the variable first. So I'm going to put the x first, and then it's pointing to the x, so it still needs to point to the x, and then 14 thirteenths. So x is less than 14 thirteenths. To graph that, we put 14 thirteenths on the number line. Less than is an open circle, and less than goes to the left. You could draw it squiggled like that, or you can draw it straight like that, or you could use a colored pencil. That's the graph. This is the solution. So you will need both parts to be done with the problem. Now what we're going to do is extend your knowledge of inequalities by combining two. So what we'll do is we're going to actually solve two different inequalities, put both graphs on the same number line, and then combine them with either an and or an or, and then come up with our solution. The and solution is where the two graphs overlap each other. So if we look at this graph, they overlap in this section here. Okay, so if we look at that, if we look at that, the graphs overlap from 7 to 10. That's where both graphs appear. So the and solution for this is going to be numbers between 7 and 10. Since it's in between two numbers, we can put the bottom number on the left, the top number on the right. Our values that we want, x, are in between those two. Then there's an open circle on 7 and a closed circle on 10. So if we look at this, 7 is less than x, so 7 is less than our numbers in here, and x is less than or equal to 10, and these numbers are less than or equal to 10. So this would be the and solution for this picture. The or solution is anywhere where either one of the graphs goes. So this graph goes all the way this way forever, and this other graph goes all the way this way forever. So the entire number line has either one graph or the other graph or both graphs there. So that will be all real numbers. Oh, you can't see that. So the or solution for this first problem is all real numbers. The notation for that looks like this, or you could just say all real. Okay, second problem. So all of that so far was this first picture. Okay, second picture. The and solution is where the two graphs overlap. So we can see that they are overlapping from 10 up. So my and solution would be x is greater than or equal to 10. That's the and solution. The or solution would be anywhere on the number line where either graph appears. So starting here we have one graph and then we have two. So from here up we have at least one of the graphs showing. So that's an open circle, so our or solution would be x is greater than 7. So that would be the solution if we said or in between the two inequalities. This would be the solution if we said and in between the two inequalities. Last problem. We have this graph. Our and solution again is where the two graphs overlap, and we notice that they don't overlap. Therefore, our answer here would be no solution. Or we could write the empty set. Our or solution would be anywhere where either one of the graphs is at. So we have this one going from 7 down, so that would be x is less than 7. And then or, because it's split, we have the bottom half and then we have the top half, so we have to write it as two separate things. And then or x is greater than or equal to 10. That would be our or solution for that picture. So even though they're the same picture, two very different solutions. Same picture, two very different solutions. So you have to pay very close attention to whether you're doing an and problem or an or problem. Next example. So in this one, we're actually going to solve the two inequalities. So I'm going to add 4 to both sides, divide both sides by 5, then I'm going to write this with the x first. So x is greater than negative 2.4. Now I'm going to solve this one. Add 7 to both sides, divide by 5. Okay, now what we need to do is look at the graph of these, because what we're doing is combining the two. So neither one of these is the answer yet. First off, I'm going to graph from negative 2.4, open circle, and it goes up. Like that. Okay, and then we're going to graph from 5, and it's less than or equal to 5, so that will be a closed circle, and down. Okay. So for our and solution, that would be where the two graphs overlap, where there's both pink and orange. That happens from negative 2.4 to positive 5, so our answers will be in between negative 2.4 and 5. So negative 2.4 is less than x is less than or equal to 5, because our values are in between those two numbers. Okay, and if we look at that, our x values, the numbers here, are bigger than the negative 2.4. So whenever you write a continued statement like this, these have to point the same direction. If they're pointing different directions, you're not doing it the correct way. Okay, now our or solution is anywhere where either one of the graphs goes. So pink goes all the way that way, orange goes all the way that way. So for an or solution, the answer would be all real numbers. So if I had written and in here, then this would be the answer. And if I had written or in here, then this would be the answer. So you have to solve the problem, and then you have to decide. You always have to look to see whether you're solving an and or an or. And is this one or is that one? Okay, another example. So we solve this, we add 4 to both sides, we get 7. Divide by 5, we get 1.4. Then write it with the x first. Then this one, we subtract 8, we get 10, divide by 4. Now we graph the two on the same number line so we can start to figure out our solution. So 1.4, open circle, and it's greater than 1.4, so that would be going up like this. then 2.5, which would be to the left of 1.4, and it has greater than or equal to, so that would be a closed circle, also going up. So now we look at this. If this said and in here, then I would need my and solution, which would be where these overlap, and they overlap starting at 2.5 and going up. So that would be x is greater than or equal to 2.5. So that would be my and solution right there. The or solution is anywhere where either one of them appears, and that would be from 1.4 going up. So that would be x is greater than 1.4. So if this said or, then that would be my solution. Same graph, two different answers depending on whether the word is and or. Okay, one last example. Sometimes problems are written like this in one continuous thing. This would be an and inequality. You notice how with the and ones, that's when we would have a number in between two numbers on the and solution. If you go back to this problem right here, see how that's the and it's in between two numbers. Well, sometimes the problem will be set up that way from the beginning. So we could just solve this all together. First off, I don't want to use a fraction, so I'm going to times through by 5. So 5 times 3/5 is 3. 5 times 5 is 25. 5 times negative 2 is negative 10. 5 times 8 is 40. Now I don't have any fractions, I can solve the problem. So I'm going to subtract 25, but I have two ladders. So subtract 25, subtract 25, subtract 25. Negative 22, negative 10x, 15. Then I need to divide by negative 10. Divide by negative 10, divide by negative 10, divide by negative 10. But when you divide by a negative with an inequality, it switches the inequality. So this less than will now be a greater than. So I'd have negative 22 divided by negative 10 is 2.2. Then I'd have x, and then this less than or equal to will now be a greater than or equal to, and 15 divided by negative 10 is negative 1.5. It's preferable to write these with the smallest number first, so I'm going to write the negative 1.5 first, and then the point is going towards the 1.5, so keep it that way, and then x, and then this point is towards the x, and then the 2.2. So x is between negative 1.5 and 2.2. So to graph that, we would do negative 1.5, 2.2, and it's greater than or equal to, it looks like that, open circle, closed circle. And there's the graph. So this is the solution, and this is the graph. Graph, solution. Solution, graph. You have to have both.